Hello everyone, today we'll be solving the question Jump Game 7. The question is very much straightforward, in which we have been provided a binary string. In this case, it is not an array of numbers. So let's dive straight into the example. So the first example is 0 1 1 0 1 0. So it has been provided that s of 0, that is the 0th indexed element, will be always a 0 character, and we have been provided with minimum jump and max jump. So when I am at index I can jump provided that the index upon which I am jumping is also a 0 based character, and the boundary conditions are that this index must be at least minimum jumps away from the previous index, as well as maximum jumps allowed is 3. So in this, for instance, as we can say, one jump can be considered in this way, second jump can be considered in this, and third jump can be considered in this. So from 0th index we can reach to third index. After the third index we can check whether we are able to reach the last index or not, and so for this we can consider from 0 I can have minimum 2 jumps. So by minimum 2 jumps I'm able to reach the last index, and hence I'm returning true. And in this example, as we can say, we are starting from here. We have been provided minimum jumps as 2. So minimum jumps 1, 2, and maximum jumps are 3. So maximum jumps I'm allowed to take over here, and I'm able to reach this index. But from here it is impossible to reach the last index, since the maximum jumps is 3, and I'm having 1, 2, 3, 4. At least 4 jumps will be required in order to reach from this index to the last index. So in this example we are going to return a false. So checking the constraints are quite high, so that indicates that we must incorporate an order of n or order of log n based solution. So before coding up the solution, I would like you to think upon it and come back if you are stuck. So now let's see how we are going to build up the solution. So let's take an example 0 1 1 0 1 0. Again we are going to take the first example. I'm going to do a dry run so that the code gets stick into your head. 0 1 2 3 4 5. Starting from index 0, since this element is always guaranteed to be 0, at first I can check that is my last indexed array, last index element is 0 or not. In case it is 1, it is not possible for us to reach from index I to index j. And that was an edge case, but let's talk about the general implementation of our algorithm. I'm at 0, maximum jump allowed is 3, maximum jumps and minimum jumps are 2. So from 2 I'm going to reach minimum here and maximum here. Since this index is 1, so I'm going to neglect this, and I'm going to consider this since the element here is 0. So it is possible for me to move from this index to further away, but this is not going to do anything good for us, and so we are neglecting this. So let me change the color of the pen. So now we are standing here. From here I'm having again 2 jumps minimum allows me to come here. Since we are monotonically traversing through the array once, it indicates that we must use a queue here, and I'll show you while coding that why the queue is being used here. So let's start the code. I'm going to take the n as the size of the string. In case s of n minus 1, that is the last index is 1, I'm going to return a 0. Now I'm going to declare a queue and I'm going to start. Okay, at first, since it is guaranteed that my starting index will be equal to 0th, so I'm going to push 0. Since, okay, the elements of the queue denotes what at which positions we are able to go. So this helps us to know that which all positions we are accepted to reach. So I'm going to start my iteration from this. Okay, if my s of I equals to 0, then only I'm going to further proceed, else I'm going to ignore. And firstly, while if my size of the queue is not 0 and q dot front is less than plus max jump, I'm going to clear this up once I write this q dot pop. If q dot size equals to 0, then I'm going to return 0, and int x equals to q dot front if x plus min jump, and no minimum jump is less than equals to I, and I less than equals to x plus max jump is greater than equals to I. I'm going to push this, and in case at any step if I is equals to n minus 1, I'm going to return a true, else at last I'm going to return a false. So this statement allows us to eradicate the elements. So for example, firstly my queue will be having a 0, right? So I'm standing at this, I'll say okay, in case my 0 plus maximum jumps, so from 0 at max I'm able to reach 3. So this is 0, maximum jump is 3, and this is 1. So this is not true, so hence we are not going to pop any element. But as we can see here, x plus minimum jump, that is 0 plus minimum jumps are 2. So at least after 2 jumps I'll be able to reach to position 2. But in case here it is not possible, so I'm going to ignore. Next, when my eye moves to here, I'll say that my eye is in the bounds and I'm going to push that into my queue. So 2 gets pushed into the queue. Similarly, 3 gets pushed into the queue. But when I reach to 4, I'll say that q dot front, that is 0 plus maximum jumps 3. Now my I is exceeding the maximum allowable moves from the q dot front. So in that case I'm going to pop this until the time I'm able to achieve this condition. I'm going to pop and pop and pop. So let us now try to run the example test cases. So let us try to submit now. So hence we have solved the question. Thank you so much for watching this. Bye bye.